हेलो फ्रेंड्स। तो राना एकेडमी में आपका स्वागत है। हमने स्टार्ट किया 11th क्लास की केमिस्ट्री एनसीईआरटी वन शॉट सीरीज। स्टार्ट करते हैं हाइड्रोकार्बन्स। द टर्म हाइड्रोकार्बन इज इट सेल्फ the explanatory, which means compounds of carbon and hydrogen only. Hydrocarbons play a key role in our daily life. You must be familiar with abbreviated form familiar with the term LPG and CNG used as fuels. LPG is the abbreviated from liquefied petroleum gas, whereas CNG stands for compressed natural gas. Another term, LNG, liquefied natural gas, is also in news these days. This is petrol, diesel, and kerosene oil are obtained by the fractional distillation of petroleum found under the earth's crust. Coal gas is obtained by the destructive distillation of coal. Natural gas is found in upper strata during the drilling of oil wells. The gas after compression is known as compressed natural gas. LPG is used as a domestic fuel with the least petrol pollution. Kerosene oil is also used as a domestic fuel, but it causes some pollution. Automobiles need fuels like petrol, diesel, and CNG. Petrol and CNG operated automobiles cause less pollution. All these fuels contain mixture of are also used for the manufacture of polymers like hydrocarbons are used as solvents for paints. They are also used as the starting materials for manufacture of many dyes and drugs. Thus, you can well understand the importance of hydrocarbons in our daily life. In this unit, we will learn more about hydrocarbons. Classification. Hydrocarbons are of different types, depending upon the types of carbon bonds present. They can be classified into three main categories: saturated, unsaturated, and aromatic hydrocarbons. Saturated hydrocarbons contain carbon-carbon and carbon-hydrogen single bond. If different carbon atoms are joined together to form open chain of carbon atom with single bonds, they are formed as alkanes, as you have already studied in Unit 12. On the other hand, if carbon atoms form closed chain or string, they are returned as cycloalkanes. Unsaturated hydrocarbons contain carbon-carbon multiple bonds, double bonds. Hydrocarbons are the special type of cyclic compounds. You can construct a large number of models of such molecules of both types, open chain, and such molecules of both types of that carbon is tetravalent, and hydrogen is you can see you can use toothpicks for bonds and products plasticine balls of for atoms. For alkenes, alkynes, and aromatic hydrocarbons, spring models can be constructed. Alkanes, as already mentioned, alkanes are saturated open chain hydrocarbons containing carbon-carbon single bonds. Methane is the first member of this family. Methane is a gas found in coal mines and marshy places. If you replace one hydrogen atom of methane by carbon and join the required number of hydrogens to satisfy the tetravalence of the other carbon atom, what do you get? You get C2H6. This hydrocarbon with molecular formula C2H6 is known as ethane. Thus, you can consider C2H6 as derived from CH4 by replacing one hydrogen atom by CH3 group. Go on constructing alkanes by doing this theoretical exercise, that is replacing hydrogen atom by CH3 group. The next molecules will be CH3H8, C4H10. These hydrocarbons are inert under normal conditions as they do not react with acids, bases, and other reagents. Hence, they were earlier known as Paraffins, Latin param, little, affinity. Can you think of general formula for alkane, a family, or a homologous series? If you examine the general formula of alkanes, is the C6H2N plus 2. It represents a particular homolog when it is represents any particular homolog when in the given appropriate value. Can you recall the structure of methane according to VSCPR theory? Methane has a tetrahedral structure, figure 13.1, in which carbon atom lies at the center and the four hydrogen atoms lie at the four corners of the regular tetrahedron. All CHCH bond angles are of 109.5 degree. In alkanes, tetrahedra are joined together, in which carbon-carbon and carbon-hydrogen bond lengths are 154 pm and 112 pm respectively. Fit unit 12. You have already read that carbon-carbon and carbon-hydrogen sigma bonds are formed by head-on overlapping of sp3 hybrid orbitals of carbon and 1s orbital of hydrogen atoms. Nomenclature and isomerism. You have already read about nomenclature of different classes of organic compounds in Unit 12. Nomenclature and isomerism is alkanes can further be understood with the help of few more examples. So common names are given in parentheses. First three alkanes: methane, ethane, propane have only one structure, but have higher alkanes can have more than one structure. Let us write structure for C4H10. Four carbon atoms of C4H10 can be now joined either in a continuous chain and or with the branched chain in the following two ways. Butane. In how many ways you can join 5 carbon atoms and 12 hydrogen atoms, C5H12. They can be arranged in three ways as shown in structure 3 to 5. Structures of 1 and 2 possess same molecular formula and differ in their boiling point and other properties. Similarly, structures 3, 4 and 5 possess the same molecular formula but have different properties. Structures 1 and 2 are isomers of butane, whereas structures 3, 4, 5 are isomers of pentane. Since different in properties is due to different in their structures, they are known as structural isomers. Now, it is also clear that structures 1 and 2 have continuous chain of carbon atoms, but structures third, second, fourth, and 5 have branched chains such as structural isomers, which differ in chain of carbon atoms, are known as chain isomers. Thus, you have seen that C4H10 and C5H12 have two and three chain isomers respectively. Write structures of different chain isomers of alkanes corresponding to the molecular formula C6H14 are also write their IUPAC name. N-hexane, 2-methylpentane, 3-methylpentane, 2,3-dimethylpentane, butane, 2,2-dimethylbutane. Based upon the number of carbon atoms attached to a carbon atom, the carbon atom has termed as primary, secondary, tertiary, and quaternary. Carbon atom attached to no other carbon atom, as in methane, or to only one carbon atom, as in ethane, is called primary carbon atom. Terminal carbon atoms are always primary. Carbon atom attached to two carbon atoms where it's known as secondary. Tertiary carbon is attached to three carbon atoms, and new and quaternary carbon is attached to four carbon atoms. You can you identify primary, secondary, tertiary, and quaternary carbon atoms in structures 1 to 5? If you go on constructing structures for higher alkanes, you will be getting still a larger number of isomers, C6H14, has got 5 isomers and C7H16 has 9, as many of 75 isomers are possible for C10H22 and structures second, fourth, and fifth. You observed that CH3 group is attached to carbon atom numbered as 2. You will come across group like CH3, C2H5, C3H2, etc. attached to carbon atoms in alkanes or other classes of compounds. These groups are substituted as substituents are known as alkyl groups as they are derived from general by removal of one hydrogen atom. General formula of alkyl group is CnH2n plus 1. Unit 12. Let us recall the general rules of nomenclature already discussed in Unit 12. Nomenclature of substituted alkanes can further be understood by considering the following problems. Problem 13.2. Write structures of different isomeric alkyl groups corresponding to the molecular formula C5H11. Write IUPAC name of alcohols obtained by attachment of OH groups at different carbons of chain. Solution: pentane 1 all, pentane 2 all, pentane 3 all, 3 methyl butane 1 all, 2 methyl butane 1 all, 2 methyl butane 2 all, 2 methyl dimethyl propane 1 all, 3 methyl butane 2 all. Table 13.1 Nomenclature of few organic compounds, structure and IUPAC names. 4 methyl, 2 methyl hexane, lowest sum and alphabetical arrangement. 3 diethyl 5 isopropyl 4 methyl 1 4 methyl octane. 5 secondary butyl 4 isopropyl decane. 5 2 dimethyl propyl allopropionane. 3 ethyl 5 methyl heptane. Problem 13.3 Write IUPAC names of the following compounds. 2244 tetramethyl pentane, 33 dimethyl pentane, 33 tertiary butyl 2244 tetramethyl pentane. If it is important to write the correct IUPAC names of for a given structure, it is equally important to write the correct structure from the given IUPAC name. To do this, first of all, the longest chain of carbon atoms corresponding to the parent alkane is written. Then after numbering it, the substituents are attached to the correct carbon atom, and finally valence of each carbon atom is satisfied by printing the correct number of hydrogen atoms. And this can be clarified by writing the structure of 3-ethyl 2,2-dimethyl pentane. Now in the following steps, draw the chain of 5 carbon atoms. Give number of carbon atoms. Attach ethyl group at carbon 3 and 2 methyl groups at carbon 2. Satisfy the valence of each carbon atom by putting requisite number of hydrogen atoms. Thus we arrive at the correct structure if you have understood and if writing the structure from the given name. Attempt the following problems. Problem 13.4 Write the structural formula of the given compound. 3445 tetramethyl pentane heptane, 25 dimethyl hexane. Problem 13.5 Write structures for each of the following compounds where the given names are incorrect. Write the correct IUPAC names. 2-ethyl pentane, 5-ethyl 3-methyl heptane. Longest chain is of 6 carbon atoms and not found that 5, hence correct name is 3-methyl hexane. Numbering is to be started from the end, which gives lower number of 2-ethyl group. Hence correct name is 3-ethyl 5-methyl heptane. Preparation: petroleum and natural gas are the main sources of alkanes. However, alkanes can be prepared by following methods. From unsaturated hydrocarbons, hydrogen gas adds to alkenes and alkynes in the presence of finely divided catalysts like platinum, palladium, or nickel to form alkanes. This process is called hydrogenation. From alkyl halides accept fluorides on reduction with zinc and dilute hydrochloric acid with 5 alkanes. From carboxylic acid, sodium salts of carboxylic acids on heating with soda lime mixture of sodium hydroxide and calcium oxide give alkanes containing the one carbon atom less than the carboxylic acid. This process of elimination of carbon dioxide from the carboxylic acid is known as decarboxylation. Kolbe's electrolysis method. An aqueous solution of sodium for or potassium salt of carboxylic acid on electrolysis gives alkanes containing a one number of carbon atoms at the anode at cathode. Properties, physical properties. Alkanes are most non-polar molecules because of the covalent nature of carbon hydrogen bonds, and due to very little difference of electronegativity between carbon and hydrogen atoms, they possess weak van der Waals forces. Now, due to weak forces, the first four number members C1 to C4 are gases, C5 to C17 are liquids, and those containing 18 carbon atoms or more are solids. At 298 Kelvin, they are colorless and color orderless. What do you think about solubility of alkanes in water based upon the non-polar nature of alkanes? Petrol is a mixture of automobiles. Petrol and lower fractions of petroleum are also used for the dry cleaning of the clothes to remove the grease stains. On the basis of the observation, what do you think about the nature of the greasy substance? You are correct if you say that grease mixture have higher alkanes is non-polar and hence hydrophobic, and in nature it is generally observed that in relation to solubility of substances in solvents, polar substances are soluble in polar solvents, whereas the more non-polar ones in polar non-polar solvents like dissolves boiling point BP of different alkanes are given in table 13.2, from which it is clear that there is a steady increase in boiling point with increase in molar mass. This is due to the fact that the intermolar van der Waals forces increase with increase of molar size of the surface area of the molecule. Chemical properties, as already mentioned, alkanes are generally inert towards acids, bases, oxidizing and for reducing agents. However, they undergo the following reactions under certain conditions: substitution reaction, halogenation mechanism, initiation, propagation, termination, combustion, controlled oxidation, isomerization, aromatization, reaction with steam, pyrolysis, alkenes, structure of double bond, IUPAC name, propene, but 1-ene, but 2-ene, but 1,3 diene, 3 or 2 methyl propane 1-ene, 3 methyl but 1-ene, isomerism, structural isomerism, geometrical isomerism, preparation from alkynes, from alkyl halides, from vicinal dihalides, from alcohols by acidic dehydration. Properties, physical properties, chemical properties: addition of dihydrogen, addition of halogens, addition of hydrogen halides, addition reaction of HBr to symmetrical alkenes, addition reaction of HBr to unsymmetrical alkenes, Markovnikov rules, mechanism, anti-Markovnikov addition and power peroxide effect of Kharash effect, mechanism, addition of sulfuric acid, addition of water, oxidation, ozonolysis, polymerization, alkynes, nomenclature and isomerism, position isomerism, structure of triple bond, preparation from calcium carbide, properties, physical properties, chemical properties, acidic character of alkynes, addition reaction, addition of dihydrogen, addition of halogens, addition of hydrogen halides, addition of water, polymerization, linear polymerization, cyclic polymerization, aromatic hydrocarbons, nomenclature and isomerism, structure of benzene, resonance and stability of benzene, aromaticity, preparation of benzene, cyclic polymerization of ethane, decarboxylation of aromatic acids, properties, physical properties, chemical properties, electrophilic substitution reaction, halogenation, sulfonation, Friedel-Crafts alkylation reaction, Friedel-Crafts acylation reaction, mechanism of electrophilic substitution reaction, generation of electrophile, formation of carbocation ammonium ion, addition reaction, direct influence of a functional group in monosubstituted benzene, ortho and para directing group, meta directing group, carcinogenicity and toxicity, and summary. Hydrocarbons are the compounds of carbon and hydrogen only. Hydrocarbons are mainly obtained from coal and petroleum, which are the major sources of energy. Petrochemicals are the prominent starting materials used for the manufacture of a large number of commercially important products. LPG, liquefied petroleum gas, and CNG, compressed natural gas, the main sources of energy for domestic fuels and the automobiles industry, are obtained from petroleum. Hydrocarbons are classified as open chain, saturated alkanes and unsaturated alkenes and alkynes, cyclic, alicyclic, and aromatic according to their structure. The important reactions of alkanes are free radical substitution, combustion, oxidation, and aromatization. Alkenes and alkynes undergo addition reactions, which are mainly electrophilic additions. Aromatic hydrocarbons, despite having unsaturation, they undergo mainly electrophilic substitution reactions. These undergo addition reactions and only under special conditions. Alkanes show conformational isomerism due to free rotation along the carbon-carbon sigma bond out of staggered and the eclipsed conformation of ethane. Staggered conformation is more stable as hydrogen atom are furthest apart. Alkenes exhibit geometrical trans isomerism due to restricted rotation around the carbon-carbon double bond. Benzene and benzenoid compound show aromatic character. Aromaticity, the property of being aromatic, is possessed by compounds having a specific electronic structure characterized by Haeckel, Fourier plus 2 pi electron rule. The nature of groups or substituents attached to benzene ring is responsible for activation and deactivation of the benzene ring towards further electrophilic substitution and also for orientation of the incoming group. Some of the polynuclear hydrocarbons having fused benzene ring system have carcinogenic property. ये कुछ हमने इम्पोर्टेंट पॉइंट्स देखे हाइड्रोकार्बन्स के, जिसको हमने शॉर्ट में कवर अप किया है, जो कि आपको रिवीजन में बहुत ज़्यादा बेनिफिट्स होगा. चाहे तो इसके हम PDF भी भेज देंगे टेलीग्राम ग्रुप पर. तो प्लीज़ इस वीडियो को लाइक कीजिएगा, प्लीज़ शेयर कीजिएगा ज़्यादा से ज़्यादा लोगों तक, ताकि आपको और आपके फ्रेंड्स को बेनिफिट मिल सके और स्टडी में बहुत ज़्यादा बेनिफिट्स मिल सके और रिवीजन में भी इसका बहुत ज़्यादा बेनिफिट होगा आपको. तो हमने पहले से देखा, क्लासिफिकेशन देखा हाइड्रोकार्बन का, देन एल्केन्स देखा, देन नॉमेनक्लेचर एंड आइसोमेरिज्म देखा, देन उसके बाद हमने देखा preparation देखा from unsaturated hydrocarbons, from alkyl halides, from carboxylic acids, properties देखे, physical properties, chemical properties, substitution reaction देखा, halogenation mechanism, initiation, propagation, termination, combustion देखा, controlled oxidation, isomerization, aromatization, reaction with steam, pyrolysis, alkenes, structure of double bond, nomenclature, then isomerism, then geometrical isomerism, then preparation from alkynes, from alkyl halides, from vicinal dihalides, from alcohols by acidic dehydration, properties, physical properties, chemical properties, addition of dihydrogen, addition of halogens, addition of hydrogen halides, addition reaction of HBr to symmetrical alkanes, addition reaction of HBr to unsymmetrical alkanes, Markovnikov rules, mechanism, anti-Markovnikov addition, peroxide effect of Kharash effect, देन उसके बाद एडिशन ऑफ सल्फ्यूरिक एसिड, एडिशन ऑफ वाटर, ऑक्सीडेशन, ऑर्गेनोलाइसिस, पॉलीमराइजेशन, अल्काइंस, नॉमेनक्लेचर एंड आइसोमेरिज्म, पोजीशन आइसोमेरिज्म। देन उसके बाद हमने देखा स्ट्रक्चर ऑफ ट्रिपल बॉन्ड, प्रिपरेशन देखा, प्रॉपर्टीज देखे, फिजिकल प्रॉपर्टीज, केमिकल प्रॉपर्टीज, एडिशन रिएक्शन, addition of hydrogen dihydrogen, addition of halogens, addition of hydrogen halides, addition of water, polymerization, aromatic hydrocarbons, nomenclature and isomerism, structure of benzene, resonance and stability of benzene, aromaticity, preparation of benzene, preparation or physical properties, chemical properties, electrophilic substitution reaction, mechanism of electrophilic substitution reaction. Sorry. Direct influence of functional group in a monosubstitute like benzene, carcinogenicity or and toxicity. Then summary. सो ये कुछ इंपॉर्टेंट पॉइंट्स थे। अगर आप चाहें तो हम इसके PDF भी भेज देंगे आपको टेलीग्राम ग्रुप पर। प्लीज़ इस वीडियो को शेयर कीजिएगा ज़्यादा से ज़्यादा फ्रेंड्स तक, आपके रिवीजन में बहुत ज़्यादा बेनिफिट्स होगा। प्लीज़ लाइक शेयर एंड सब्सक्राइब। थैंक यू सो मच फॉर वॉचिंग।